This weekend, I went to the Formula Null e-waste hackathon in Waterloo. The goal of this hackathon was to build a car out of e-waste and then race it. I had the genius idea of building a car out of a waffle machine, but I wanted the waffle machine to actually work and make a waffle while driving. To actually get the waffle machine to cook while driving, I needed the waffle machine to be battery powered, and I decided to make it run off of USB-C so I could plug it into either my laptop or a battery to power the waffle machine. Normally, waffle machines use AC power and accept 120 volts from the wall, but I took mine apart to see how it worked and to figure out how I can convert it to DC power. I found out that the entire waffle machine is basically just two resistive heating elements in parallel, and the total resistance comes out to 43 ohms. To power this waffle machine using the resistor, I needed to inject as much power as I could into the machine to make it heat up as much as possible. I used common parts that I could find on Amazon for the hackathon, so I bought a USB-C power negotiator that can request 20 volts at 5 amps. I also bought a DC to DC boost converter, which can step up the voltage from 20 volts to 40 volts. Using Ohm's law at 40 volts across 43 ohms, the power output comes to about 37 watts, which is still about 10 times less powerful than what this waffle machine was supposed to be when plugged into AC power at 120 volts. Using a portable charger, I powered the USB-C waffle machine and successfully cooked a waffle. It took about 10 minutes to preheat and about 20 minutes to cook, but at the end I had a fully edible waffle, all without plugging it into the wall. With this setup, I can now use the same waffle machine to cook waffles inside a moving car, whether it's a real car or it's an e-waste car. Even though this waffle machine would drain any battery, it still can only barely cook a waffle, giving it 20-30 minutes to actually cook it successfully. While I was working on the waffle machine, the rest of the team was working on actually making a e-waste car. So once I had the battery-powered waffle machine ready, I put it in the car, hooked it up to a battery, and the robot was ready to race. Before racing, I had interference issues with my controller, where it would pair with a different team's robot. I was able to control the robot without them knowing why the robot was randomly moving. They thought something was wrong with the robot, when in reality, I just had the controls to their robot.
Reset it.
Once we had the robot built and driving, we competed in races against other teams. Here are clips from some of our race highlights.
Alright, how was it racing out there against all those other small cars?
It was a lot of fun. This robot destroyed them all.
There seemed to be a lot of haters out there in the crowd. What would you say to them?
Well, I would say that they were in my way and I couldn't get by, so there was no other way to get around the race other than to plow them.
Yeah. So, alright, can you talk to us a little bit about the engineering that went behind this robot? Like, what were you kind of going through?
We took motors for big robots and we put them on a very small robot. So it was super powerful and no one could defeat us. Additionally, we had a 10x speed boost. So if anyone got in my way, I could just do the 10x speed boost and completely push them. Nobody could push us out of the way.
Alright, do you think that the other robots were original in any way, or do you think ours was having the waffle on it, something else?
Yeah, there was one team, they're actually racing right now, they have a toaster on it, but they did not enable their toaster with a battery. This waffle machine was enabled with a battery and was able to make a waffle while driving. How do you think we did in this race today?
I mean, I feel like we were one of the faster robots. We made it to the Grand Prix final. Was there casualties? Yes. But at the end of the day, we were a fast and effective robot and we crossed the finish line.
Is there anything we could have done better?
I think our robot was a little big, and if we made it a little bit smaller, it would have been a bit more fair. But overall, I think we did a good job.
Do you think it's fair to push other robots out of the way?
I'll give you my on the record and off the record. On the record, it's not okay to push robots. Off the record, you're on the racetrack. Like, blood is the name. All right. It doesn't matter who. You can just run them over.
Was it fair for the penalties that we received?
I think some of them were unfair as other robots were driving in front of us. Controversial opinion. But overall, we should have been more attentive. I do agree with that. But I think then again, like, it's part of the game, you know? Like, we built a robot that had a waffle maker on it and that was durable. And all these other guys, I didn't see much e-waste, so I don't know. I think they should be disqualified.
Because the robot was so big and kept destroying other robots, we were disqualified and won the award for biggest loser, winning a large bag of charcoal. I love hardware hackathons like this one, and I look forward to the next one. Like, subscribe, and comment what you want me to see build next.